Welcome everyone. In this video we will derive the formula for centripetal acceleration. And to do that I will draw a circle. Great. And the center of our circle is here. The center is here. We have a radius of length r. We have a particle, let me draw it with, blue. A particle here which is traveling at a speed of v, and this speed is constant. All right, v is a constant. So we are dealing with uniform circular motion. The speed is constant, and our particle has a position vector which we can call r. And last but not least, the angle here is theta. So given these, what we can do is we can write our position vector. Well, then our position vector will simply be equal to r times cosine of theta x hat, right? This part. And of course, remember that the magnitude of our position vector is equal to r. That's why I wrote r here. R times cosine of theta x hat plus r times sine of theta y hat. Of course, our coordinate system is like this, x and y, the most generic coordinate system that you can find. But it does the job for us, so we will be using it. What about the components of our velocity? Let's write Vx. Well, Vx will be equal to, we need to do a little bit of geometry here. So I draw a horizontal line here. We know that this angle is theta. And this is a very important thing. In uniform circular motion, the position vector and the speed, the velocity vector, are always perpendicular to each other. So this angle here is a 90 degrees angle. All right. Since this is 90 degrees, this part here is 90 degrees minus theta. And if I draw a vertical line like this part is theta. So using that, we see the Vx, the x component of our velocity is equal to V sine of theta, right? This part. And it is negative because it is pointing in the negative direction. For Vy, we have V cosine of theta, this part, and it is positive because it is pointing in the positive y direction. Now we have everything we need to find the magnitude for centripetal acceleration. We are looking for AC, let's call it. We are looking for it. Then we will take its magnitude. Okay, so we will find the formula for centripetal acceleration. And you might be wondering, how can we have an acceleration in this case? You told me that the speed is constant. Well, the speed is constant, but remember that speed is not a vector. Speed is a scalar. It is the magnitude of our velocity. So the magnitude of our velocity is constant, but the direction of our velocity is not constant because we are constantly changing direction. That's why we are moving in a circle. Hence, even though the magnitude of our velocity vector is constant, its direction is changing, so there must be an acceleration. And we call that acceleration a centripetal acceleration. Great. Then by definition, the acceleration in the x direction will be equal to the derivative of the velocity in the x direction with respect to time, right? So we write this, and how can we do it? Well, let's just substitute what we have. We have this, and dt. Now we will use the chain rule to take this derivative, right? And I think I've done a video about chain rule. If I haven't, I will do. It is a very, very useful thing that we use all the time. So I say d theta, then I multiply it with d theta dt. And now I will take the derivative. The derivative of, well, first of all, we take v out, right? Because it is a constant. We have v. The derivative of sine of theta with respect to theta is, what was it? I know that I derived this formula. What was it? It was cosine, right? It is cosine of theta. And we have a negative, so it is negative cosine of theta times, what is d theta dt? Well, it is simply how much the angle changes as time passes. So at full revolution, 2 pi is the angle that we have traveled through, and the period, capital T, is how much time it took. So it is basically 2p divided by 2 pi divided by t. So we have 2 pi over t. And notice that since we are traveling in a circle with constant velocity, we know that 2 pi r is equal to our velocity times the period, right? So velocity is equal to 2 pi r divided by t. Using this information, let's multiply our expression with t. So we have t here and a t here. Now we see that this is a v. So we have two v's, which means a v squared cosine of theta, and we have r as well. All right. Now we will do the same thing for the y direction, and I will do this a little faster since we went over the x direction in great detail. So instead of dvy, I am writing dv cosine of theta. Right, I just copied and pasted from here. And we can take v out. We will use the chain rule. We remember that the derivative of cosine of theta with respect to theta is equal to negative sine of theta. And just like we discussed, d theta over dt, well, that will be 2 pi over t for our situation. If we multiply the top and the bottom by r, we will have v here, so we say v squared sine of theta all divided by r. And now we have finally found the components of our acceleration vector. So let's write it. Our acceleration vector, which we called centripetal acceleration, is simply ax in the x direction plus ay in the y direction. In the ax direction, we have, we have negative v squared cosine, cosine of theta divided by r. And for the y component, we have v squared sine of theta divided by r. I put the negative here, and it is in the y direction. Great, so we have done it. This is correct. But let's simplify a bit. Simplify this a bit, shall we? Let's simplify. Because it is always better to leave things as simple as possible. So I am factoring out the greatest common multiple. In this case, it is negative v squared over r. And we are left with cosine of theta x hat plus sine of theta y hat. Does this expression seem familiar to you? It is very close, right? It is very, very close. So let's make it the exact same thing. Let's multiply with r. A r here and a r here. But since we multiplied, we need to divide by r as well. So a square here. And now we can say negative v squared over r squared times our position vector. This is the formula for centripetal acceleration. The negative sign here indicates that the centripetal acceleration is always towards the center because it is opposite in direction with our position vector, which is from the center to the position of the particle, basically. And if we want to consider the magnitude of our centripetal acceleration vector, well, we can just remember that this is true, right? Where r hat is the unit vector along the r vector, the position vector. So if we consider that, if we substitute that here, you see that these two r's will cancel, right? This and this, they would simplify, leaving us with v squared over r. And of course, we don't put the negative because this is a magnitude. And actually, this formula here is known more than this one right here. But this one is more general and it gives you information about the direction and all that kind of stuff. But you are welcome to use any one of them. And as I said, you will encounter this formula more often. I hope that you enjoyed this video. If you have any comments or suggestions, please write them in the comment section below. I hope to see you in another video. Until then, take care.